Bill Nye, the man of science, has been thrilling us with the latest discoveries and unraveling old mysteries for decades. He has piqued our interest in the final frontier and its enigmas, introducing us to the vastness of space that surrounds us and stretches infinitely above. Now, Bill Nye breaks his silence on the most recent images from the James Webb Space Telescope, offering us a glimpse into the universe as it was more than 13 billion years ago, fundamentally altering our knowledge of the cosmos and our perspective on life itself. This telescope is making groundbreaking discoveries about planets, distant galaxies, and much more. It is a revolutionary scientific breakthrough and a worthy successor to the Hubble Space Telescope. But what is so special about these images that defy our expectations and theories? And what does Bill Nye have to say about them? The creation of this telescope was the result of years of work by NASA scientists and engineers, launching on Christmas Day 2021. The various steps of its deployment proceeded smoothly over the next few months. By the end of June 2022, scientists began discovering thousands of new galaxies, older and more distant than previously known. Some of these galaxies might have formed 150 million years before the oldest discovery made by Hubble. In addition, the telescope is able to capture enough light from celestial objects such as exoplanets and stars to reveal their composition and trajectories through space. Bill Nye states that this data is already beginning to reveal, in great detail, the atmospheric composition of planets light years away from Earth, allowing scientists to make suggestions about their potential to harbor life. One of the Hubble Space Telescope's most iconic images has long been the pillars of creation in the Eagle Nebula. While Hubble primarily detects visible light, it could not capture the processes of star formation within these pillars. However, the Webb telescope's infrared imaging has revealed numerous protostars, clusters of dust and gas several times larger than our solar system, appearing as tiny red dots against the background of the pillars. These protostars are in the early stages of formation, not yet burning hydrogen. As more material is attracted to their centers, they become denser until nuclear fusion begins, causing a dramatic rise in temperature to about 2 million degrees Celsius. The different colors in Webb's images represent infrared wavelengths, mostly invisible to the human eye, while the only visible part appears blue. Bill Nye highlights that these images not only demonstrate Webb's infrared capabilities but also provide unprecedented insight into the formation of stars like our Sun. The first exoplanets were discovered in the 1990s, and today, more than 3,000 confirmed exoplanets orbit distant stars. However, only about 1,000 have been directly imaged. Most exoplanets are so far away that they can only be detected when the light from their host star is dimmed. The first direct image of an exoplanet was taken in September last year. This planet, identified in 2017 and named HIP 65426b, was observed using coronagraphs on Webb's cameras, allowing astronomers to block out light from its host star. HIP 65426b is a massive gas giant, nearly 12 times the size of Jupiter. Its great distance from its star, 100 times the distance between Earth and the Sun, makes it easier to observe. In addition, Webb's outstanding infrared sensitivity enhances the ability to study such planets. Although the ghost galaxy is difficult to see in the sky, its brightness can be captured with infrared imaging. The spiral arms of the galaxy and its array of stars radiating from the center are visible in optical views of the object, also known as M74. However, a recent Webb image reveals structures resembling filaments of heat-emitting dust and gas emanating from the galaxy's bright center. This new image illuminates star-forming regions scattered along the galaxy's spiral arms. A stunning composite image, combining data from both the Hubble and Webb space telescopes, highlights optical and infrared views of the galaxy. Produced by researchers at the European Space Agency, ESA, as part of the PHANGS project, this composite utilizes observations from ground-based telescopes alongside Hubble and Webb. By using Webb's sharp infrared capabilities, astronomers can better identify star formation regions in galaxies and accurately measure the masses and ages of star clusters, as well as the properties of tiny dust particles in interstellar space. In July last year, an image of a distant star known as WR140 displayed an intriguing diffraction pattern, a characteristic artifact of imaging, but was also surrounded by a series of concentric rings with a slightly square shape. These rings, in contrast to diffraction patterns, are caused by the intense stellar winds of Wolf-Rayet stars, which are in the late stages of their evolution. The interaction between WR140 and a smaller companion star gives rise to these peculiar ring shapes. The Webb telescope is designed to detect the most distant galaxies in the universe. In mid-December last year, researchers announced the detection of 4 of the oldest known galaxies, seen for the first time by Webb. These galaxies date back 13.4 billion years to a time when the universe was only 350 million years old, just 2% of its present age. These discoveries were made as part of the JADE strategic survey using the near-infrared spectrograph, which allows scientists to rapidly measure the distances of galaxies. The redshift of these galaxies, which measures how much their light has been stretched due to the expansion of the universe, reached a record-breaking value of 13.2. For the first time, Webb allows astronomers to locate potential proto-galaxies and confirm their extreme distances spectroscopically. Meanwhile, Webb has also conducted one of the most extensive studies of an exoplanet in the constellation Virgo. This planet, named WASP-39b, is located 700 light-years from Earth and orbits its star at a distance much closer than Mercury is to the Sun. This Saturn-sized gas giant experiences extreme heating as it orbits its star. Webb's observations reveal that its atmosphere is dominated by thick clouds containing sulfur and silicates, including sulfur dioxide. Scientists were able to identify carbon dioxide in its atmosphere using 2 of Webb's spectrographs, marking a significant breakthrough in exoplanet research. Let me know your thoughts in the comments. If you enjoyed this video, remember to like and subscribe, and I'll see you in the next one.